during the exam. And if you want to get to these formulas, a lot of questions will include the formulas, but if you need one copy of the preparation quiz. All right, some of these are definitions and some of them are things that we have to work out. So it says, in the numeral 357, the 5 position represents, and that represents what? So we're going from the 1s, and then that's going to be the 10s position. Using the table, write the given Egyptian numeral as a Hindu Arabic numeral. All right, so here is the symbols that we're going to use, and we see there's 3 of these, what we call these scrolls, and that's worth 300. So we have 300 plus, and then we see 2 or 3 of these rather, which is 3 times 10, 30. And then we see 1, 2, 3, 4 of the singles, so 4. So this is equal to 334. Write the numeral below as a Roman numeral, and here's your Roman numerals over here. And so we have 70 first. So 70 is going to be LXX. And then we have a 6. And remember how we write 6? We write it V and I. So V and then an I. Using the table, write the given traditional Chinese numeral as a Hindu-Arabic numeral. And remember, we start from top to bottom and we go in groups of 2. So let's start at the top, and we take the top symbol and we look at the value of that, and we see that's worth 4, and it's going to be over a power of 10. And if we look across the table, we see there's 1,000 there. So we've got 4 times 1,000 plus, now we look at this next symbol, and we notice that that's a 0. Okay, so basically it tells us there's nothing here. So we're not going to have anything at this position. And then down here we have this symbol, which is worth 6. So this is equal to 4,006. Okay, going on to problem number 6. We're using the Ionic Greek now, and we want to write this number in Ionic Greek. And we see 800, and we see there's a symbol here for 800. So I'm going to go ahead and circle that. And then we have a 0, and then we have a 5. And so the 5 is right here. And so we're looking for this, looks like a W and then an epsilon, and that's given right here in this answer choice. Complete the expanded form for 81. So remember how we do that. So this is going to be 8 times 10 plus 1 times 1. Write the Babylonian numeral as a Hindu Arabic numeral. So the equivalent here is going to be, so remember what the positional values are, 1 and 60. So we've got 1, 2, 3, 4, 5 of these symbols, which are worth 1 each. So we've got 5 times 60 plus, here we've got 10, and this is the symbol for subtraction, minus 3 is 7. So 5 times 60 is 300, so this is equal to 307. Write the Hindu Arabic numeral as a Mayan numeral. All right, so we've got 160, and if you remember the positional values in there go 1 and then 20. So we're going to take 160 and we're going to divide by 20. And we get 8. So we know that, and remember, these also go vertically. So we know in the position for the positional value, remember again, I said there were 20 and then 1. We need to have a symbol that's worth 8, and then we have nothing down here because we didn't have any remainder. If I write that here, there's a remainder of 0. So the symbol for 8 is right here, and then we want a 0 underneath of it, which is here. So the correct answer here is A. Convert the numeral to a numeral in base 10. So remember how we do that. We write that in expanded form, and we have 2 positions here. So this is worth 1, and this is worth 4. So this is equal to 3 times 4 to the 1, plus 2 times 4 to the 0. And 3 times 4 to the 1 is equal to 12, plus 2, and we get 14. Now we want to convert a number from base 10 to base 4, and actually kind of nice because we had the base 4 up here. And we have to figure out the highest positional value in base 4 that's less than 106. So let's take a look at our numbers. So we have 1, 4, and then 4 squared is 16, and 16 times 4 is 64. And if I go one more space and I take 64 times 4, I get 256, which is too much. Okay, so I'm going to take 106 and I'm going to divide by 64. So if I put my calculator over here so you can see it, I'm going to take 106 and I'm going to divide by 64, and I see that I get the 1, which I know. And then again, I need my remainder. So how did I do remainders? Subtract the number, the whole number part. So subtract the 1 and then multiply by the number you were dividing by, and I get a remainder of 42. Okay, now that's going to drop down to the next positional value, which is worth 16. So I'm going to take 42 and divide by, oops, again, 42 divided by 16, and I get 2. And again, I need my remainder, so I'm going to subtract my 2 and then multiply by the 16, and I get a remainder of 10. Okay, and then I'm going to bring this up here. I'm going to drop down to my next positional value, which is the 4. So 4 goes into 10. I can do that in my head. That goes in 2 times with a remainder of 2, and then 2 over 1 gives me 2. So what I get is 1, 2, 2, 2. So my answer here is, let me get back to my blue pen, 1, 2, 2, 2 in base 4. And in medieval times, people referred to the golden proportion as the what proportion? Golden proportion was also called the divine proportion. Determine whether the given sequence is a Fibonacci type, and if it is, then determine the next two. So remember Fibonacci, we take the sum of the first two, add them together, and we should get the next term. So 1 plus 2 is 3, which is not the term shown here. So this is not a Fibonacci type sequence, and we can't find the next two terms. Assume Sunday is represented by day 0, Monday by day 1, and so forth. If today is Tuesday, determine the day of the week, it will be in 82 days. So remember what we do here. We take 82 and we divide by 7, because we're on a 7-day week. That's our modulus. And we get 11. And again, I want the remainder, so I'm going to subtract the 11 and multiply by the number I was dividing by, and I get a remainder of 5. And so if I was here on Thursday, if I count ahead 5 days, Friday, Saturday, Sunday, Monday, so it would be Tuesday, which is right here. And then now we're going to do the months of the year, and we've got to go 88 months ahead. So we're going to take 88 and divide by 12. 88 divided by 12 gives me 7. And again, I want the remainder. So I'm going to subtract the 7, multiply by 12, and I get a remainder of 4. And if I'm currently in April, I want to go to ahead of May, June, July, and so it will be August. If neither principal nor the interest is guaranteed, the investment is called what? And that's called a variable investment, because nothing's guaranteed. The rates could change and the principal amount could also change. A loan on which you pay a fixed amount of money for a set number of payments is called a fixed what? That's called a fixed installment loan. Okay, now we're going to do one with increasing a population. So we've got a population of a particular country, and in 1990, it was 235 million, and now it's up to 277 million, and we want to know the percent increase. So remember how we do this. Where we are now, which is the 277, minus where we started, which was 235, and then we're going to divide by where we started, and when we're finished, we're going to multiply by 100 because we want it as a percent to 1 decimal. So in my calculator, I'm going to take 277, subtract 235, I get 42, and now I'm going to divide by 235, and then go ahead and multiply by the 100 to get the percent, and I get 17.9% rounded off. So the answer here is 17.9% increase. Use a circle graph here. So the library classifies DVDs into several categories, and there's a total of 1,975 DVDs, and we want to know the number of science fiction, and they've given us the percent of science fiction, but we want to know the number. So what do? We take the percent, divide by 100, and then multiply by, to get the decimal, multiply by the total number of DVDs that the library owns. So I'm going to take 7 times 1975, and then divide by 100. And we're going to round to the nearest number because we're talking about DVDs, so this would round off to 138 DVDs. And you can check that now by taking 138 and divide by the total number of DVDs, which was 1975, and make sure that you come out with, and you do 7% when it's rounded off. Okay, we want to do some simple interest now. Simple interest, here's our principal, and remember simple interest, I equals PRT. This is one formula you do have to memorize. Okay, so my interest is going to be my principal, which is 1406.42. And my rate here, and again, now I'm going to have to convert this to a decimal. Let me put this over here. So the first thing I want to do is change the fraction to a decimal. So I'm going to take 4 divided by 5, and I get 0.8, and then I'm going to add that to 1. So this is the same thing as 1.8%, but then again, remember, I want to divide it by 100 because I need the decimal in order to make the formula work correctly. And then my time here is 11 months, and this is the interest per month. So I don't have to convert this to an annual because this is an interest per month. Okay, so we're just going to go ahead and multiply then straight across. So we're going to take our principal, 1406.42 times 0.018 times 11 months. And I get 278.47. $278.47. That's my simple interest. Okay, this is the one where you're trying to figure out where loans are due and the number of days between two dates. So we want to go from, and we're not doing a leap year, from March 24th to November 9th. So on my table, I'm going to find March, which is the third column, and I'm going to go down to the 24th, which is right here. And I want to go to November 9th, which is right here. And so all I'm going to do then is subtract. So I'm going to take 313 minus 83. And that will tell me the number of days between those two dates. 313 minus 83 gives me 230 days. So the answer here is 230 days. Okay, and then there's one at the bottom of this page too. Let's see. So Karen invested $13,000, interest rate of 1.25% compounded semi-annual. 4 years later, she withdrew the full amount to put toward a down payment on a new house. How much did she get back? Okay, so her principal is $13,000. Her interest rate is 0.0125. And it's compounded semi-annual, so N is 2. And the time is 4 years. Okay, so this is one where you could go back to the first question on the exam and look up that formula, which is right here. Compound interest formula right here. So P parenthesis 1 plus R over N to the NT. Okay, so we're going to put this in as the amount. So it's going to be P 1 plus R over N to the NT. All right, and her principal is 13,000, 1 plus, and her interest rate was 0.0125 over 2, and then it's 2 times 4 in the exponent. Now I'm just going to go ahead and do this all in my calculator without stopping. I'm going to start inside the parenthesis with the fraction, 0.0125 divided by 2, add 1. Okay, my exponent here is 2 times 4, which is 8. Here's my exponent key on this calculator, so I'm going to raise that to the 8th power, and then I'm going to multiply it times the 13,000. And so I come up with, she's going to be able to withdraw 13,664.40 when we round it off, because we're talking about money, so we're going to round off to 2 decimal places. All right. Now we're doing one with an effective annual yield. And again, this formula is also, let me find my formula page again. This one here, effective annual yield for $1 invested at 5% compounded monthly. And again, you also have this formula right here. Annual percentage yield, 1 plus R over N to the N minus 1. Don't forget to minus that 1. So we've got, so the APY is equal to 1 plus, and my interest rate here was 5%, and it's compounded monthly, and that's raised to the 12th power, and then you subtract 1. All right, so let's do that in the calculator. Again, I'm going to start inside with the parentheses, 0.05 divided by 12, plus 1. Okay, so now I've got the quantity inside the parentheses. I'm going to use my exponent key to raise that to the 12th power. And then finally, I have to remember to subtract the 1. And if you remember, this is always slightly larger than the quoted interest rate. And let's see what our answers are possibly here. And so it's going to round off to 5.12%. It's a multiple choice question. Okay, we're going to do a monthly payment for an installment loan. And again, you have the formula up here. Installment, monthly payment, mortgage payment formula are both the same. Don't forget in the denominator, there's a negative exponent there. All right, so let's write our formula over here. So our monthly payment is going to be the principal, which is $950. The interest rate, which is 0.09, and it's compounded, we're doing 12 per year, divided by 1 minus 1 plus 0.09 over 12 to the negative 12 times, and there's only 1 year, so that makes it a little bit easier for us. Okay, I'm going to simplify. Let's do the denominator first. Okay. Let's do the denominator first. So 0.09 divided by 12, 0.09 divided by 12, plus 1. Oops. Now, I need to raise this to the negative 12 power. So my exponent key, in this calculator, I have to put my number in first and then hit the negative key. And you're always going to get a number here that's less than 1. Okay, so then I'm going to use I have a store option in this calculator. So I'm going to store that number in space number 1. Then I'm going to take 1 minus, and I'm going to recall that number I just had. And I get 0. I'm going to jot it over here, 0.08576. So that's my denominator. And again, I'm going to store that so I don't have to enter that back in. Then I'm going to simplify my numerator. 950 times 0.09, and then I'm going to divide by 12. So I get 7.125. And then I'm going to divide by that denominator, which I stored in my calculator. Oh no. And I get $83 and looks like 8 cents when I round it off to 2 decimal places because we're talking about money. So the monthly payment there would be $83.08. Okay, this one is a principal and interest formula tape, but we're going to use the table here. So what you need to do is figure out how many thousands are in your mortgage. So you're taking 65,000, first step, and divide by 1,000. And when you do that, you're going to get 65 $1,000 units. Now you're doing 8% for 15 years. So look at my table. I'm looking at the second column, and I'm doing 8%. So here's my multiplier right here. So I'm going to take this number and multiply by the number of $1,000 buckets or units in my mortgage. So 8.55652 rather times 65. And I get a mortgage payment of $621.18 rounded off. Oh, 17 cents. I apologize, should be 17 cents. Yes, 17 cents. Okay. And the next one, the formula is actually here for you on this one. The next two actually have the formula shown. This is an annuity problem. And they want to know how much the accumulated amount in the annuity will be. And we've got 30 years, 6%, and we're putting $900 in quarterly. So my amount is going to be, so we're putting in $900. See if I can focus that a little bit better. Yeah. $900. And then I have a lot of stuff going on up here. 1 plus, and I need the interest rate, 0.06. And we're compounding quarterly, so this is over 4. And then it's raised to the 4 times the number of years, which is 30. And then inside here, we're going to subtract 1. And then my denominator is simply going to be 0.09 over 4. All right. So let's see. I can do my numerator first, and then I can divide by my denominator all in one set of calculations. I'm going to start inside here. 0.06 divided by 4 plus 1. And my exponent is 4 times 30, which is 120. So exponent 120. I'm going to subtract 1. And then I'm going to multiply by, there were $900. $900. And so just in case we lose anything here, I'm going to go ahead up here and jot down what we've got so far. So we've got 447, 447, let's say 39. And then we're going to divide by, and I'm going to use my parenthesis key so I make sure that this gets divided first before it divides into the numerator. 0.09 divided by 4, right paren, and I get 198,000, which is not correct. Let me check my answers here. It's not correct. Let me go back for a second. Somewhere I've made a mistake. All right, let's double check here. 1 plus, should be a little bit more than that. So 900, 1 plus R over N, compounded quarterly. 4 times 3 is 120, minus 1. Okay, let's try it again. And I'm going to store this time because somehow I made a mistake. All right, so let's go inside the parentheses. 0.06, whoops. Let me divide the denominator first, actually. 0.09 divided by 4 gives me, so this comes out to be 0.0225. Okay, now let's do our numerator. So 0.06, oh, there's my mistake. This is 6. There's my mistake right there. There we go. I figured it out. All right, so it'd be 0.06 divided by 4. There we go. 0.015. There's my problem. Now, if I take this and divide by that, I'll get the right answer. 447, 2.39 divided by 0.015. That's better. Yes. Okay. All right, let me start from the beginning because I'm a little bit off in my sense. So let's start in the beginning. There's where my mistake was. I put in a 9 here instead of a 6. So 0.06, I'm going to do the numerator again. 0.06 divided by 4 plus 1, exponent 120, okay, minus 1 times 900, okay? And then I'm going to divide by, divide by 0.015. There we go. That's got the right answer now. Let me put it over here. So it should be 298,159.37. My apologies. I wrote the number incorrectly down here, and that's why I was getting the wrong answer. But this is the correct answer here. Now we're going to go the other way. How much do we have to put in periodically in order to accumulate a certain amount? So we want to accumulate 170,000. And let's see, our interest rate is 0.07. And the number of compounding is monthly. And then we're going to divide by 1 plus 0.07 over 12. And we're going to raise it to the 12 times how many years? 27 years. And then you do a minus 1 here. Okay, let me simplify the 12 times 27, just so I know what that is, 324. So my exponent, I'm going to jot it down here, is going to be 324. Okay, let's do the denominator first, and then we can store it in the calculator. All right, so we're going to take 0.09, make sure I got the right interest rate. No, 0.07, see that? 0.07. 0.07 divided by 12 plus 1. Exponent, remember I calculated my exponent before, is 324. And then I'm going to subtract 1. And I'm going to go ahead and store that in my calculator. And I'll jot that down in case you want to see it. It's 5.58312.031. Store it in my calculator. And then I'm going to do my numerator, which is I'm going to take the 170,000 times 0.07 and divide by 12. And I'll jot that down in case you want to see that intermediate step, 991.67. And then I'm going to divide by and call out that number I had in the denominator, and I get 177.62. So my monthly payment I need to make is 177.62. So when you take this and divide by this, you'll get that payment. Okay, now we're going to go on to unit 3. Determine the slope of the line between the given points. Okay, so remember your slope formula. Okay, and we'll let this one be 0.2 and this one be 0.1. It doesn't make any difference. So we're going to take 8 minus 3 and divide by 4 minus 2. So I get 5 over 2. So the slope is 5/2, which you can put in as a fraction. I think you can also, I think they want a fraction. Find the equation from the graph. Okay, so notice it goes through the origin. So there's not going to, the y-intercept is basically 0. And we need to find the slope. So let's go from, let's see, I'm trying to see what points would be easy here. This point here. So how do we get from this point to this point? Okay, we go up 5 and over 1. So the slope must be 5 over 1. So therefore, this must be y equals 5x, which is answer B. All right. Now we want to know if this is the graph of a function. So remember the vertical line test. If we draw a vertical line and it crosses the graph in more than one place, it is not a function. All right, Jackie's Rent-A-Room recently advertised the rental of a full living room set for a down payment of $98 and $45 per month. Here's the equation that models the cost of renting a living room set. If you want to rent the set for 9 months, how much will it cost? So you're going to let M equal 9. So you're going to say C equals 45 times 9 plus 98. And we're just going to go ahead and simplify that in our calculator. So we're going to take 45 times 9 plus $48. And we get, oh wait, I did something wrong. $45 per month for 9 months. Let's try it again. 45 times 9 plus 98, 503. So it's $503 if you want to rent the furniture for 9 months. Okay, exponential. The number of certain bacteria in a culture is represented by this equation, and where x is the number of days. We want to know how many bacteria would be there after 5 days. So y equals 2,000 times 4 to the 5th. Remember, order of operations, we have to do the exponent first. So we're going to take 4 exponent key to the 5th power, and then we're going to multiply it by 2,000. And we have a lot of bacteria there. We have 2,048,000. Big number. Okay, now we're going into unit 4. So a path that passes through each edge of a graph exactly one time is what kind of a path? And that's going to be an Euler path. And now we want to identify a graph that has 4 odd vertices. So remember what we mean by that. That means an odd vertex has an odd number of edges coming into it. So let's take a look at what we have here. So we want to know 4 odds. Okay, so let's take a look at this one. So let's see if they're odd. This is odd. This is odd. 1, 2, 3, 1, 2, 3. Those are all odd. So that might be it. Let's just take a look here. 1, 2, 3, 4. This is even, so I can eliminate this one. Let's see. 1, 2, 3, 4. 1, 2. Eliminate that one. And then this one's got evens also. So the correct answer here is A. Identify any bridges that are in the graph, or maybe there's none. Okay, so a bridge is an edge. If I take it out, it creates a disconnected graph. And I see that right here. If I took this edge out, the graph will become disconnected. So the correct answer here is B. And then determine if this graph is connected or disconnected. So is there a path, and these large circles represent the vertices, is there a path from every pair of vertices between every pair? And they are, so that's a connected graph. And now we're going to take a look at some voting methods. Oh, did I skip a page? Hold on just a second. 34. Hold on, we're out of order here. Like I'm missing a page. Oh, you know what? I know where it is. Hold on just a second. Here we go. I had it in my copier and I forgot to put it back in order. I'm missing the page. I thought we had more on graphs. We do here. So use the following graph. Find an Euler path that starts with A. So remember, a path goes through each edge one time. All right, so let's take a look at this one. And we have 4 choices here. And one says no Euler path exists. Let's take a look at the vertices first. Let's see what we have. This is odd. Let's take a look at our odd and evens. Remember what Euler's theorem helped us with that. So what are the odd vertices? A is odd, B is even, D is odd, and C is even. So we've got 2 odd vertices. So we know that there's going to be an Euler path, and it's going to start with one odd and end with the other one, right? We know that because that's the way it works. And if I look at that, it has to be C. Let's take a look and make sure that makes sense. A, C, D, A, B, D. Yep, it's answer C. And now we're going to do Hamilton circuits. And Hamilton, remember, goes through each vertex one time. And we want 2 different ones here. And these are going to be circuits. So the first thing I would look and see if I can eliminate, because remember, a circuit has to start and end at the last same vertex. So I can eliminate this one. And all the other ones look like possibilities. So let's take a look. So we've got B. Let's see if B works. So we go A, E, C, F, D, G, B, A. That looks pretty good. I'm going to put a little arrow there. Let's take a look at C. And C goes A, B, G. Now G doesn't connect with F, so I can eliminate that one. There is no edge between G and F, so I can't do that one. How about this one? A, E, C, over here, D, G, B, F, A. That looks like a possibility. This one looks too short. Let's see. A, B, G, D. So yeah, that goes around the outside, so that's not correct. So it's B and D. All right, now we want to create a spanning tree. Remember, spanning trees, they take out edges while still maintaining a connected graph. So let's take a look at what could possibly be a spanning tree. Well, this is not correct, right? Because this has formed a disconnected graph. It's not connected anymore. On C, there's still some edges we could take out. We could take this edge out, okay? Because that's causing a circuit there, and we don't want that. So this is the correct answer here for this one, B. And then now we're into our voting methods. So fill in the blank. Voting method in which each candidate is compared with each of the other candidates is called which method? So what's that method called? And that is called the pairwise comparison method, which is the first answer. Okay, the mathematics department had an election for department chair, and we want to figure out the winner by plurality and if the winner had a majority. So all we're going to look at are the first place votes. And so let's take a look at J, S, and C. And how many total votes do we have also? So we have 17. So we have 28 total. No, that's not right. 17 and 12, 29, it looks like. Let me double check on my calculator. I don't want to make a mistake. 7 plus 10. Oops. 7 plus 10 plus 4 plus 8, 29. Yeah. All right. So let's see. Jones has how many first place votes? 7, 11. Smith has 10, and Clark has 8. Okay, so Jones would be the winner. Now, if it's a majority, it has to be more than 50% of 29, which means it would have to be 15 or greater. So Jones wins, but doesn't have the majority. Okay, this is looking at whether a majority criterion is satisfied, and I have a detailed solution on the next page so that you didn't have to sit here and watch me write all this stuff out. And this will be posted with this copy of the quiz. So here's the table, and we're going to use the board account, and then we want to determine if the majority criterion is satisfied. So there's 4 candidates. So first place is worth 4, second place 3, and so forth. So I went through the 4 candidates and I figured out how many points they would get using the board account method. And A has a total of 19, B has 24, C has 12, and D has 13. So B wins by board account. Now, is there anybody with a majority of the first place votes? And there's only 2, 4, 6, 7 votes in here. And if we take a look, A has actually a majority of the votes, okay, but A didn't win. So therefore, the majority criterion is not satisfied on this particular election because candidate B won by board account. So if we use a board account, we violate the majority criterion. Okay, and then some things on apportionment. So the first one is to find a standard divisor. So we have 166 seats and we want to figure out the standard divisor. So what we have to do is add up to get the total population. So 1283 plus 2374, 25, 27, 27, 25, 2155, 1592, 2511, and 2017. Okay, so my total population is 14,657, and I'm going to divide that by the number of seats to be allocated, which is 166. And so I get a standard divisor of about 88.30, which is answer D. And now we want to find a standard quota on this problem. So the first thing I want to have to do is find the standard divisor. So I need the total enrollment. So 233 plus 297 plus 153, and I get 683. And then I need to divide that by the number of scholarships, which is 25. So divide this by 25, and my standard divisor is 27.32. And then they want me to find it just for the mechanical engineering department. So I'm going to take 233 and divide by the 2732. So 233 divided by 2732, and I get 8.53, which is answer C. Okay, fill in the blank. A standard quota rounded up to the next whole number is called a what? And that's called the upper quota. When a group A loses an item or items to B, even though A's population grew at a faster rate than population B, which paradox is that? And that's called that's the population paradox. And then one final question. And again, I have a detailed solution on a separate page for this one. They want to know, here's a bunch of provinces and we have 300 federal judges to apportion. And does the Alabama paradox occur using Hamilton's method if the number of judges is increased from 300 to 301? And again, I have a nice detailed solution that you can find in the same location as this exam. So the first thing I did, I put this in Excel. It's easier for me to put in all the numbers here and I got the total. And then I said, okay, so the standard divisor is this number divided by the 300 judges. So then I took each population divided by the standard quota to get the standard divisor, rather get the standard quota, rounded down. I had 4 extra seats to allocate, 4 extra judges rather, and they went to B, C, F, and G. No, F, I'm sorry. 4 more. So I had 1, 2, 3, and 4. There's where they went. Now, if I went up to 301, my standard divisor is a little bit different. It's now 585. Same steps down here. And when I did my lower quotas, I only added up to 297. So I had 4 more judges to allocate, and they went to B, E, F, and G. Now, did anybody lose a judge? Okay, none of these provinces lost anything. G gained a judge, so therefore the Alabama paradox did not occur. So hopefully this quick review of one copy of the final exam prep quiz will help you get ready for your final exam.